Welcome to part one. Let's continue where we left off. So we had created, I think we had created all the classes. We just hadn't written any implementation. So let me expand this and then do that. So we have color splasher, noisy splasher, solid splasher, UJImage. Then color splasher, noisy splasher, UJcolor, UJImage. So that's pretty much all we have, right? So we need to implement UJImage. So we need to implement UJImage first, then we can continue to the other classes. So since I am now inside the CPP file, so let me try and build just to see if I have any errors. Okay. Oh, that function has not been created yet. So we are not on file handling yet. We'll get there when we get there. So the stream insertion, and now I can give my parameters names. Why am I now giving my parameters names? Because now I want to access those values of those parameters. So I'm going to have obj right hand side and then obj left hand side. So how will this operator function actually work? So let me show you how it actually works. So remember, you say we want to be able to say C out, and then let's say obj1, right? This is what we're trying to be able to do. And if you check, let me just, okay. If you check obj1, let's say obj1 is of type UJImage, like this, right? But then we know C out, right, is of type OStream. That's C out. So under the hood, C out is declared like this. And as you can see, this is how the operator is going to get used. What's the operator? Is the stream insertion. So I'm inserting UJImage into the output stream so that it can be displayed. So another way of using this operator is to say cout dot operator like this, and then obj1. That's another way of doing it. But this way, this is when the operator function, this operator function, that's when it's part of the OStream class. Right? That's why we do this notation. Remember the dot notation. It means go to that class and get that specific function or that variable, all right? So this should be implemented as a friend function instead. So what does that mean? It means that it should be called as like a normal function like this, and then you pass in the parameters. So on the left-hand side, I'm going to take in C out, and then on the right-hand side, I'm going to have obj1. So these two lines over here, they're equivalent, these two lines. It might not look like it, but they're actually equivalent. The reason why we do it this way is because this is like the mathematical notation that we used to. Remember, the mathematical notation is you have a value on the left-hand side, and then the mathematical operator in the middle, and then you have another value on the right-hand side. So we can use it to use it in that using that notation because we are used to mathematics, right? That's where we're coming from. If you look at everything, it's a foundation. It's base. It's primary core. It's primary foundation. It's maths. Even in computer science, it's all maths. It's a glorified maths degree. So that's why this notation is possible in C++, so that it helps you. It helps you like excuse me. It helps you to be able to learn and understand things like operators or operator overloading easier. Excuse me. So these two things are exactly the same, right? You can use it in that way or use it in that way. So if it's used in this way, this means it's a non-member. Why am I saying it's a non-member? Because I didn't say some object and say dot. I didn't do that. You see how the function was used like this. But then when that function is used, it's exactly the same way as this. Exactly the same thing. So the order matters. The order matters. So don't start by passing UJImage here. Then you pass the OStream object. Don't do that. Order matters. So we need to decide, right? So this, I feel like this print function, this operator, we need to wait a bit on that. So let me scroll down. Okay, so the stream operator for outputting creates a P3 image string and then sets it into the stream. So they want you to create a P3 PP image. That's what they want you to do. But I don't see why you do that, because remember, okay, it's fine. Okay, it's fine. Let's do that. So they told you to create a P3 image string, right? Remember, P3, it means that it's in RGB, red, green, and blue, right? It's a color image. That means that image has colors, like those bright colors like orange, purple, green. That's a P3 image. So how do we output the P3 image? We start by outputting what type of image it is. So I'm going to output P3 if it's P3, P2 if it's P2, and then P1 if it's P1. And then I'm going to insert an end of line character, and it's from the standard namespace. And then since why am I doing it in this way? I don't want to put the semicolon and then I have to type O left hand side again. I don't want to do that. So what I can do is I can just remove that semicolon and tell it to just continue inserting. So what's the next thing you need to display? It's the number of columns. So where do we get the columns? From the image, from obj right hand side. So obj right hand side. And remember the rule. Friend functions, they have access to any members, even private ones. Why? Because remember, a friend has access to your secrets, right? Which is private to you. But you can tell your friend your secret, right? Or give access to give access to your friend something that's private to you. You can do that, right? So the same thing in the real life, it works the same way here. So friend function can be able to access private member variables. And then there needs to be a space between the columns and the rows. Then I output the rows underscore rows. And then I put an end of line character. And then after putting the end of line character, I need to output the maximum intensity. The maximum intensity is up to you. Because remember, an image is basically a file or a text file, something like that. So either way, whether you put it as 255 as a string or as an integer 255, either way, it doesn't matter. So I'll put it as an integer 255 for the maximum intensity. Basically means what's the maximum that each pixel can have. It's 255. And then I need to go through all of my rows and columns to get every single pixel. So I'm going to have a for loop. So for unsigned short r is equals to 0. R is less than obj right hand side dot underscore rows r plus plus. And then let me zoom out a bit. And then I go through all of my columns. Unsigned short c is equals to 0. C is less than obj right hand side dot underscore columns, because that's the object that I want to print the pixels from. So I need to access its rows and columns. And then now I need to insert the pixels into my output stream or my O stream object, so that it gets displayed on what? On the output on the console. So how do I insert? It's simple. You just say the OStream object like this. Remember, the OStream object is basically mimicking cout. We've just called it used a different name. It's still the same thing as saying cout, then you output the red color, followed by a space, then you output the green color followed by a space, then you output the red color, the blue color followed by a space. So pretty much the same thing as using cout. We just used a different name for it. We cannot use cout again. Why? Because cout is already defined in the standard namespace. So that's why I'm going to call mine O left-hand side for the O stream object, which is on the left-hand side when this operator is used, which is true. Because look at which side the O stream is. It's on the left-hand side. And look at which side the object was, right-hand side. So now I'm going to access my OBJ. And remember, we can access private member variables. So underscore pixels in that specific row and column. And then I need to get the red color component. Remember, it's RGB, red, green, blue. You need to output them in that order, followed by a space. And then obj right hand side dot underscore pixels, that specific row and column. Get the green color component dot green, and then followed by a space. And then obj, if you don't put the spaces, it's not going to display well. RC dot blue, and then put the space there. And then after each pixel, we need to move to the next line. So not after each pixel, after each row. So when you're done going through all of the columns in that specific row, then we do what? We output an end of line character. So all left hand side is equal. You insert the new line character. And then once we're done, remember the function expects you to return an OStream object. Then it's going to point to that address of that OStream object. So it expects us to return the physical OStream object. So return O LHS. And then that's pretty much how you insert into the output stream. And then the constructor, remember we do constructor chaining. So I'm going to chain to my constructor. So I'm going to put a colon there, followed by the constructor. So which constructor do I want to chain it to? We always chain it to the fully parameterized one, basically the one with the most parameters, which is that one. It's up to you. You can chain it to this one, it's still the same thing, but I like to chain it to the fully parameterized one. So this will be default. Okay, seems like we do not have constants. Maybe they're there, just not appearing. Let me just double check. Yeah, they are there. So it's just not taking it into account. It's fine. I'll just type. So it's default underscore rows. No, what am I? And then default underscore calls, and then default underscore pixel. So what this does, it tells this parameterless constructor to go to a constructor with 3 parameters. Copy and paste that code here. So it's going to paste the code here inside this constructor, but then replace where the first parameter was used with default rows. Then replace where the parameter was used with default, the second parameter was used with default calls. And then replace the third parameter with default pixel. So yeah, that's pretty much what it's going to do behind the scenes. So we don't have to repeat the same code over and over again. And then we have the constructor that takes in only 2 parameters. So I'm gonna have this one, and then I'm gonna chain it UJImage. Okay, come on, UJImage, and then we're gonna have not default rows. Why not default rows? Why? Because we're now taking in the rows and the columns. So I'll just pass those rows and columns. But I'm missing a pixel. So this one, since it's not taking in a pixel from the user, it is going to use the default pixel. So default underscore pixel. It's pretty much the same thing as that that parameterless construct. Yeah, so let me do that. So we have this. So there's our constructor chaining. And then there's the fully parameterized one. So rows, calls, and then pixel. But remember, we're going to have an assignment operator, if I'm not mistaken. Yeah. So I did create helper methods for the constructor and helper methods for the destructor. So I need to go and implement those, then call them inside of my destructor and my constructor. So this one will mimic the helper methods will always refer or will always mimic the constructor that is all the parameters. That's why here I have 3 parameters, because the constructor with all parameters is the one with 3 parameters. And then I'm going to set just set the size, right? So underscore rows is equals to that rows, underscore columns is equals to those number of columns, and then underscore pixel is equals to, now we're instantiating our pixel array. Remember, it's going to be dynamically allocated, meaning that it's not, the size is not known at compile time, it's known at run time, meaning when the application actually runs, not when we are building it. So new UJ color, pointer, and remember what we have been talking about. The pointers here represents, you can think of them representing one dimension. So we start by allocating the outermost. You replace each pointer with square brackets, and then within the square brackets, you provide how big that dimension should be. So this will be as big as the number of rows, and then I'm going to go through all of the rows and sign short r is equals to 0, r is less than underscore rows, r plus plus, and then I go through all of the rows in my array, right? That's why I'm indexing like this. I'm going through all the rows within my array. Every single row should be instantiated or set to a new UJ color of size columns. So remember, we had 2 pointers, right? The outermost one has been already allocated. There it is here. Now we're allocating for the innermost one, which is this one. So we replace that with square brackets. Then we provide the number of columns. And then that's pretty much all we have to do. But then remember, we have a pixel to set it to. So the reason why we typically put an inner for loop here, this is why. Because if you didn't do that, that means at the bottom here, you'd have to say unsigned. Okay, that means at the bottom you have to do this. Let me just copy and paste this, just for the sake of trying to save time. Then delete. So this would now be, this inner one will now be underscore calls, and then this will be C, right? So as you can see, we kind of repeating the same thing. I could just remember, now I'm supposed to say the pixel. So the pixel is a specific coordinate, RC row column is equals to that pixel that I'm getting from this, from that's being passed as a parameter to this function. So you see that, yeah, this is not really a problem, but you see that I'm going through the rows again. Whereas I could just see, okay, this previous code, it's already going through the rows. What's missing is for me to go through the columns. So therefore, I'm gonna take that code, instead of doing it twice, repeating myself, let me just do it once. And then I'm gonna come here and then I'm gonna put that for loop there. So that's why we combine the for loops like this. Because immediately after setting it, I now know that at every single row, there's a column. So I can now go through my columns. Then now I've actually found the coordinate. Remember, the coordinate is coordinate RC, basically row and column. But in maths, this would be on a Cartesian plane, this would be XY. So it's pretty much the same thing. And then which pixel are we setting it is to this pixel over here. That will be passed when this helper method is invoked or called. So this will be obj right hand side. And then I simply copy the object, right? So for unsigned short r is equals to 0, r is less than obj right hand side dot underscore rows r plus plus. And then for unsigned short c is equals to 0, c is less than obj dot underscore calls. So now I'm going through all of my columns. Then now I've gone through all of my rows, and then at every single row, I'm going through every single column within that one row. So after I've at that specific location, now I can get my pixel. So underscore pixels at that specific row and column should be set to that object obj right hand side dot underscore pixels at RC. And always remember that when it comes to copy constructor, right? When is the copy constructor invoked? It's invoked when you say UJImage obj1, and then you use the assignment operator immediately whilst you are declaring. That's when the copy constructor is called. So let's say this is now equals to obj2. Let's say previously there was UJImage obj2. So this technique will call the copy constructor. But if you do it this way, right, you declare the object separately, and then you say obj1 is equals to obj2 like this. This now requires what we call an assignment operator. So you need to overload the assignment operator in order to copy it like this. And this would be a deep copy. And then the previous one, which is this would be what we call a shallow copy. Why shallow copy? You'll see why. You see, there's my pixels array, and I'm copying values from this object. What if this is, let's view it in terms of liters, right? What if this is 1 liter, and then I'm trying to pour from a container which is not, let's say 5 liters. So you see, obj right hand side is 5. It could be 5 times bigger than my actual array. So that means I won't be able to copy everything in the array. Why? Because if you look at it actually cause a compile time error, a runtime error, I mean. When it's running, you see that I might go beyond the size of this array. If it so happens that this one on the left-hand side is 1 liter or smaller, and then the one on the right-hand side is bigger, because look at which rows I'm using. Rows from my object. So like in my rows, you see the object is bigger. It's 5 liters, and then the object that I'm trying to copy from is 5 liters, which is bigger. And I'm trying to point into a 1 liter, which is smaller. So it will cause the program to crash. Just know that it will cause the program to crash. So this is why we call it a shallow copy, because you don't actually copy everything, and you're doing everything hastily. You don't make sure that are they of the same size, things like that. You don't do anything. You just copy. So it's a shallow copy. And then here, it's time to deallocate memory. If you look at how we allocate memory, how do we allocate it? You see that for every single row, we had a set of columns. Right, so I need to delete those columns first. So I need to go through every single row and find short r is equals to 0, r is less than underscore rows r plus plus. And then after I've gone through every single row, I delete that memory. How do you delete? You say underscore pixels, and then you index into that row. And then for the index for the columns dimension, right, you leave it empty to say that you're emptying it out. You want to empty it out. But then C++ syntax it requires you to put that empty columns before the array, before the underscore, right? Or just after the delete. So delete, and then, which just means delete this whole dimension at this row. That's literally what it means. Because why? If you look at here, at every single row, we allocate it to be of this size columns. So you don't specify what size you are deleting, you just delete. Okay, I'm putting it in the wrong way. I need to put it in the helper method. Then call the helper method. So after I've deleted all my columns, now I'm left with what? My rows dimension. So I need to delete that. So I say delete underscore pixels, right? Empty it out. But remember, C++ syntax, it wants you the square brackets to put them after the delete keyword. So there it is. And then remember not to forget to carry connection. Why am I always saying connection? Let me show you. Draw .io. Okay, I'm just gonna quickly demonstrate this so that you kind of understand. But I think I did talk about the stack and heap. Yes. Yeah, so what happens when you realize why we need to cut that code? Remember, every time you use the new keyword, right? When you use the new keyword, it allocates memory on a separate place. So we always have what we call the stack and heap. I think I did explain this, if I'm not mistaken. I think I did explain this. So we have the stack and heap. Not me saying stack. We have the stack and the heap memory, right? So I'm gonna enlarge the text. So this will be the stack, right? You can think of the stack as like you always remove from the top, right? Something like that. And you don't have to worry about that knowledge. It's not applicable in the scenario. Just know stack, that's where all the variables are stored, right? So what happens when you say new? So remember the stack is like I said, the stack you can view it as like your grandparents' place, right? When you visit them, you don't do anything. Everything is done for you. So you're basically, the stack is basically allowing you to be a couch potato, to be lazy and not do everything's done for you. Your granny cooks for you and they wash your dishes for you. They ask you if you have any laundry that you need to do, bring it here, I'll wash it for you. They do everything. They wash after you've eaten, they wash the plates for you. They're like, no, sit down, don't worry. I'll wash your plates for you. Don't stress. Sit on the couch. So that's the stack. If most of the things are done for you, the memory allocating, the memory deletion is done for you by the stack. When you take a conscious decision and you say you want to use the heap memory, what you're saying is that you want to be responsible. That means every new keyword that was used must be accompanied with a delete. So you see two new keywords here. How many delete keywords do you see here? Two. So you need to make sure you delete the memory. So what happens when you use new? So when you use new, what happens is this. It's like, for example, you have a variable here. Okay, let me just use the copy and paste this. So remember we have our variable here, underscore pixels, right? So let's say it's underscore pixels. Come on. It's underscore pixels, right? And I said the underscore pixels should be allocated, um, should be a new UJ color big enough as the number of rows. So what this does, right, it creates some box. Just think of some box that's big enough to store, that's big enough, that is its dimension or its size is the same as the number of rows. And then it returns when you allocate something on the heap memory, wherever that box has been created, has been stored, there's the new keyword, it returns the address of where that object resides. So that address gets stored inside pixels. Remember, to store addresses, use pointers. That's why we made pixels a pointer, because we wanted to allocate memory on the heap. So when you're deleting, this is what happened. You start to understand why we need certain things, right? Like setting it to now point. So what happens when you say delete? It means you're saying that box I was working with, ne, on the heap, delete it. So it deletes it, but you still have this pointer. You're still pointing there. But what are you pointing to? You see, there's nothing. But it doesn't know that you're not pointing to nothing. It will try and access it. That's when your program crashes. It just jams. So what we can do is we can say that instead of just jamming, our program just jamming, it should tell us that we try to point to a location that's non-existent. How do we do that? By setting it to null pointer, which is a \0. So by redirecting this arrow and say go point here. So now we now point to null. So now when you try a reference and go and access, it's going to say, wait, you're pointing to nothing. What are you trying to do? That's when you get what we call a segmentation fault error. That's what that means. So This would be underscore pixels is equals to null pointer. Remember null pointer under the hood, it's literally like this. You can think of null pointer like this. I want you to imagine it as this. It's const int null pointer is equals to 0. That's under the hood, that's how it's implemented. It's just a 0. To indicate that there's nothing. Remember what the number 0, what it means. It means the absence of something or the absence of a value. That's 0. So hence null pointer. So now why null pointer? Because we are dealing with pointers. When you're using the heap memory, what do you use? You use a pointer. So we're dealing with pointers. Hence they've named it null pointer. So that's what that part does. So that we get this error code segmentation fault, which tells us that we are trying to locate a non-existent box. So you try to go to a non-existent or point to a non-existent box. If we set it to null pointer, it will raise that error. It will say segmentation fault, which will be very good because if it gives us that error, then we know that we know what the error is instead of it just pausing and then just and then it just jams in front of you. We don't want that. So that's pretty much all the helper methods, right? So let's call them. So remember this distractor, I need to call my distractor method, helper method. So this is just going to go copy and then paste it here. That's pretty much what the function call does. And then I'm gonna go back up. Then I'm gonna go back up. Let's go back up. Let's go to our constructor. So yeah, this is the fully parameterized one. So this one is simple. I just call the constructor helper method, which expects me to pass in the rows. So I pass in these rows over there. So pass those rows, comma, and then it even highlights to show you which parameter you're currently passing. You see now it's blue. It means that I'm currently passing the second parameter, which is called calls. So it expects me to pass columns. So I'm going to pass calls here, and then you see now it's highlighting the third parameter. It was coloring the third parameter in blue to show me that that's what's expected. That's the third parameter. It's anything that's of type UJ color. So yeah, it's called pixel. If you check there is UJ color pixel. So what this does just goes that helper method goes into the code, copy and paste it, and then replace the first parameter with this value, this one. The second parameter's value, replace it with that value. The third parameter's value, replace it with that pixel. And then copy constructor, obj right hand side. You just call the copy constructor method copy constructor, and then it expects an object. So I pass in obj right hand side. And then these are accessors. These ones are pretty easy to do. So we're just going to say return underscore rows, and then return underscore calls. And then to get the color, we're obviously going to need a row and a column to specify which row and column are we getting the color. And then we could do an enforce range, right? It's up to you whether you have time or you remember it. But enforcing the range is something very important. So let's do that. So I'm going to add a helper method. How do you know it's a helper? Because it's been made private. So helper, and then I'm going to call it check range. Let me call it check range, right? It's going to take in 3 values. An unsigned short, which represents the actual value, and then an unsigned short again, which represents the minimum that is expected, and then another unsigned short, which represents the maximum that is expected. So I'm going to copy this and then go back to UJImage.cpp, and then just right before the destructor, I put it there. Then I'm going to do this so that it can fit on the screen. And then this will be the value that I'm checking, right? And then I'm going to compare it against this minimum. Don't use words like min, because if you use min, what you see that it's already highlighted in bold green. So it means that it's already reserved. So you have to say minimum value or minimum or lower, whatever you want to call it, and then maximum. So I have these values, value parameters, I mean, value that I'm expecting to check, and then this is the minimum range that it should be in. This is the maximum range that it should be in. So I'm going to need to exit the program once once the conditions are not met. So what I'm going to do is I'm going to include the C standard library, right? Because I need the exit function to exit. And then I also need to create, now I'm forced to create an enum. So let me see. Okay, we could put exception handling, but let me focus on doing the enum. So let's create an enum, and then I'm gonna call it status. For my application status, right? We're gonna have error in range. Let's say it starts at -1 and then success. I'll add onto this, the more we continue, I'll add onto this list. So why am I saying -1? Remember, enums by default increment by 1. So if I start at -1, that means the next constant or the next value will be the previous value plus 1. So you see, it even tells you what's the value. It's equals to 0. So success is equals to 0. And then if I hover over this one, it should show me that it's equals to -1. So that's why I started at -1. So now I can make use of the exit function. So I'm going to go back to UJImage.cpp and then just simple check. So I'm going to check if there's a value that I've received. Check if it's below the expected minimum. So how do I check? That means it's less than the minimum. What should happen? I just output an error. So standard CR and then and say, what's the error? So the error is that value that you are checking happens to be less than the expected minimum of, and then a space, and then I continue typing or in continue setting into the stream. It's less than which minimum, this expected minimum value. And then I put an end of line character. And then after this, I'll put in that error message. I need to exit, call the exit method. It's not complaining, but I think it's in the standard namespace. Let me see. Okay, it's not in this case. It's fine. So I'm just going to say exit to exit. It expects me to pass a constant, some integer. So we've created an enum to give those numbers meaning so that it's easy. Our code becomes readable. Because if I just say -1, you don't really know what that means. But if I say error in range, you see, it means that exit because there was an error in range. And then I'm pretty much going to do the same thing that I did here when I'm checking if it's greater than the maximum. But then now I'm checking if it's above the expected maximum. Maximum, like this. And then I'm just gonna change this to maximum. And then now I need to change my string to not say that it's less than the expected minimum of, no, I should say that it's greater than the expected maximum of this maximum value, and then exit with error in range. And then now I can do a lot of checks before allowing things to happen. So where should I put the checks? It's very important. Is the it's where the fully parameterized constructor takes call the helper method. Where the helper method is called, I need to check just before just before it gets called, or I actually check in the helper method. It's up to you where you want to check. So here I need to check my rows and columns and pixel range values, right? Since I'm now going to check my rows and my columns, and my pixel. I need to create constants for that because if I just plug in numbers, you in the future understand that just plugging in numbers is not good. Don't plug in numbers. So I'm going to create a static const unsigned short and say default, not default, minimum size, right? What's the minimum size for my app? It can be minimum size 0. There can be no rows at all or no columns at all. That's fine, but 0, not negative. And then the maximum size, we just put in an arbitrary big number. So remember short, unsigned short, right? It stores from 0 to 64,000. So I can put in any number within that range. So let's say our app, we expect it to be like at least 20,000. That's the maximum number. 20 is too big. Let's say 10. And if you didn't know, C++ has this feature whereby I think it's C++ 14 or C++ 17 standard version. And then there's this thing, this apostrophe. You can put an apostrophe to make the number easier to read. So I'm going to put the apostrophe there. Now it's easier to read. Oh, this is 10,000. It doesn't change the number. It's just for other programmers when they're reading to make it easy to read. So I have minimum size and maximum size, and then I need to have a static const int, not int, unsigned short, and then I'm gonna have minimum pixel size. What's the minimum pixel size, right? It might not make sense now, but you need to have code whereby it's easy to read. You don't just have plugged in values. We call those magic numbers. You do not want magic numbers. By magic, it's because in the future when you're reading your code, you'll be like, wait, where did this number come from? It's like it's magic. It's like it came out from nowhere. It's like the magic trick was done. So we do not want that. So we need to create constants. So max pixel size. What's the maximum intensity? 255. And then I'm going to take this and then go to my. Oh, no, it's fine. I can just type it down. But remember, when we're printing into the string stream, 255 already has a constant now, so I can change that 255 here because I don't want it to be a magic number. Because when I read this, I might know that it prints a P3 image, but I'll forget what this 255 means. So here I need to say max pixel size. We should have 255, but at least your code is easy. It's easy to read because now I'll see, oh, my columns for the object, my rows for the object. Oh, this is the maximum pixel size. Oh, okay. You see, it becomes easy to read. So I'm gonna scroll down and then go here. So I need to check all of the values. So I need to check range, and then I need to say check my rows and check against what value. Minimum size, right, comma, maximum, max size. So remember if we're counting zero base, so if it's starting at 0, then you must stop at max size -1. That it doesn't really matter, but yeah, you need to understand your math, right? So you could just change this to 9,999. You could do that, that's fine. And then here you don't have to put the -1. That's fine. How you do that, how you decide to do that. And then check range for my columns. I'm comparing I'm comparing them against the exact same size. So there's nothing much I need to change there. And then make check range, compare what pixels red color component to start between the minimum pixel size, meaning 0, and it stops at exactly that value, right? Max pixel size. Didn't I save this? Yeah, I did. I guess you're just not picking them up, but that's fine. And then I'm gonna do the same thing because I need to check all of my color components, right? This is red, green, and blue. I need to check all of them. So dot green, then dot blue. After I've checked, right, then I can create my object because I know I'm now 100% sure that they're within the right range. Then I'm gonna scroll down. Let me see. I just want to double check. Okay, so there's nothing missing at the bottom. Then yeah, so all of my constructors have been dealt with, have been handled. Now, yeah, okay, I remember I was here at the accessor get color. So I needed to create that method. Why? Because I want the user to enter a valid row in the valid column. I don't want them to enter spiritual numbers. So I'm gonna say check range, check what? I'm checking that value row against what values. Remember, it starts at 0, so I already have a constant for that. I'm gonna say mean size, and then up to underscore rows -1 because it's 0-based counting. Start counting from 0, you stop at the number before. And then check range for my column, but now I'm checking it against the number of columns. So if it's out of those ranges, then we know that this user is trying to access a pixel that you can't access. That's non-existent. And then return underscore pixel. Once the checks they've passed, then I can just return the pixel. Remember the check range function, right? If nothing happens, it won't exit. If it's false, because remember I'm using if statements. If this is true, then do that. If this is also true, then do that. So if none of them were true, nothing happens. That means they were true. If none of them were true, that means all of them were false, meaning that the values were actually within the right ranges, so we do not have to worry. So there's nothing to do. The application continues as expected. And then let me just do this so that we can see it fully on the screen. And then unsigned short to set the pixel, you have row, then column, and then the pixel you want to set it to. So it's going to be quite a long journey because you have to keep validating, checking. So I'm going to do this, right? So I'm going to check my row as usual in the column. Then I'm going to check my pixels, every single pixel. So pixel dot red, check it against the minimum pixel size, and then against the max pixel size. Okay, since I don't want to keep typing, let me delete that and then put this one. Then now I can just check my green. After checking my red color component, then I check my blue color component. And then I think I'm missing a closing curly brace now. Yeah. So let me put a closing curly brace. And then now once we've checked every single thing, each color component's range, the rows range that I'm trying to access, that specific columns range that I'm trying to access, if all of them are valid. Remember, if none of this was true, then it just continues as usual. But if one of them becomes true, that means it's going to exit, the program is going to crash. And then return no set, I'm setting the pixel. And then now set the pixel. So what pixel? It's underscore pixels at a specific row, at a specific column, set it to pixel. And then that's it. You set the pixel, but remember you need to check the range. It needs to be valid. You can't just set things just because you feel like setting them. And then remember the operator overloading, we did talk about this, obj right hand side. So I need to avoid self-assignment. The self-assignment right here. So assigning to myself, it's already the same value, then it's fine. So I'm gonna use this keyword, which stores the address, right? So if this address is not equals to the address of the object on the right hand side, they need to not be equals. If they're equal, that means the same value. There's no need for me to assign. And then if after I'm done with everything, this expects me to return the current UJImage instance, right? How do I do that? I use this keyword and then I dereference because this keyword is a pointer. So if you just return this keyword, it just returns the address, which is a pointer. This function does not return a pointer. It returns a UJImage. So I need to dereference or point to that address stored in this variable. Then I get the actual object. So what's the order here? You always delete any memory that was there. So I'm gonna call my helper method destructor. That's easy enough. And then I'm going to allocate memory to match with obj right-hand side. So I need to make sure they're of the same size. Remember what we talked about? What if you have a 5-liter container that you're trying to copy from and you only have a 1-liter container? That means you won't be able to pour everything. So how do you make sure we pour everything? We allocate. So I'm going to call my function construct helper method constructor. Remember, it expects you to pass in the rows and the columns and the default pixel. So I'm going to say obj right hand side dot underscore rows, and then obj right hand side dot underscore calls. And remember, there's multiple functions, right? Remember, constructors, I mean. Remember, we also have the constructor with 2 parameters. So I can just leave it there and then that's fine. So I'm just going to use that one with 2 parameters. I'm just going to keep it simple. I won't use the one with 3, then pass default rows, default pixel, I mean. I won't do that one. And then the last one is to now copy the values since objects are now of the same size. So now we can copy the values. So how do we copy? Remember, we have a helper method called copy constructor, which takes in the object we're trying to copy from. I'm trying to copy from obj right-hand side, which is this object here. And then we are done with that. Yeah, we're done every method. So now I'm just left with, let's implement this operator here. Let's quickly check what it's supposed to do. So support for negation operator. What does that mean? So it loops through the array. So let's do one thing at a time. Let's loop through the array. Let's do that. So let's loop through our pixel or our image, right? Or our pixels. So R is less than underscore rows. And remember, you have the option to implement these methods in whatever way you want to implement it, whether as non-member or member methods. That's up to you. Underscore calls C++. Right, so we've gone through the pixels. So let me do this. And then sets all the red, green, and blue color components to 0. And then they say the probabilities must be left as is. So the probability, just leave it. Just set only the color components, all of them to 0, which is very simple. So underscore pixels, that specific row and column, dot red color component, set it to 0. Underscore pixels, that specific row and column, dot green color component, set it to 0. And then underscore pixel, that specific row and column, dot blues color component, set it to 0. And then they said the probability don't do anything. So probability is fine. We're just going to leave it. That's pretty much all I'm going to do here. I'm going to leave the probability because that's what they tasked you to do. So yeah, we've done operator overloading. We're done with that. So if you go down to the mark sheet, operator, so you already have 15% in full for operator overloading. And then we have some of the marks here. This test is very easy to pass if you do everything and you know what you're doing. So, okay, what's missing now? Oh, the delegation part. So let's go back to delegation. Where do they start talking about UJImage? Okay, UJImage is a color splasher which implements the splash non-value returning, so it returns void method that will set the pixel attributes of the UJImage according to the instructions given above, right? So the UJImage delegates its own splash method to the contained color splasher. So how do we delegate? It's simple. You just call that function, the other function. So what I'm going to do is, they said it shouldn't return anything, so void. So if you check in my header file, I do have color splasher, right? I did do for declaration. So I need to include this header file here because I'm gonna make use of the method within the color splasher. So I can't say call in a method and then here I only did for declaration, which is an empty class. So it's going to say non-member function does not exist. So hence in the CPP file, we need to include the header file for color splasher. So that when we call the methods to delegate, then it knows, oh, that method actually does exist. So before we do that, we need to instantiate this, right? We need to instantiate the color splasher because why? Its memory is managed, its life cycle is managed by UJImage. So must manage life cycle of color splasher object. So we need to go to our, remember we created helper methods. So I need to put in any code to allocate or to deallocate inside the helper methods. So I'm going to go to my constructor method data is here. And then I'm going to write a comment here and say life cycle management. So I need to I need to instantiate a splasher. So underscore splasher. Okay, this thing is not auto-completing. Underscore splasher is equals to new color splasher, right? And when use new color splasher like this, right? This calls the default constructor. So hence you need to have a default constructor or not default, a parameterless constructor inside color splasher. Because what this line of code does, it invokes that parameterless construct. So it needs to exist within color splasher in order for this to work. So what I'm saying is here, I'm saying create a variable splasher and then instantiate memory big enough to store as a color splasher on the heap and then return the address of where that box is stored and store it inside splasher. And then we need to also delete. Remember, I'm deleting the object's memory, not an array. So I don't use square brackets. I just say delete underscore splasher. And then I'm going to say splasher underscore splasher is now pointer. So that we get a segmentation fault if we try to allocate this memory when it was deallocated. So this is also lifecycle management. So I'm going to say, okay, let me put it above the delete keyword. Life cycle management, right? So that's life cycle management. And then, okay, I'm gonna scroll down, life cycle management. Okay, that's it. So we've managed life cycle, we've dealt with that. Now we are left with delegation. Because you cannot delegate if you don't access, what is allocate memory. We need to allocate memory. Remember underscore splasher splasher. How come it's not helping out? I need to stick to Visual Studio. Underscore splasher. It's fine. The spelling is fine. Underscore splasher. Dot. You see, I can't say dot. Why can't I say dot? Because splasher is a pointer. Remember how pointers work. If you use the pointer, the name of that pointer, without the actual pointer, that star, then it actually refers to the address. If you want to get the object, you need to dereference or point to that address. So I need to point at this address, then get the object. But then after pointing here, sometimes C++ will get confused. Let's say, for example, I have a splash.run method, right? Something like this. If you leave it like this, right? C++ gets confused. It's like, do you mean this whole thing is the address? Or you mean Splasher on its own is the address. So it gets confused. So hence that's why we typically put brackets around it to say, okay, I mean only splasher is the address. Then dot now access, because this will get me the object. Dot, then I call that splash method within splasher class. So, but then sometimes this notation, you see, it's a bit cryptic. So an alternative, it's up to you. No one's forcing you. An alternative to this is to say an arrow like this minus greater than. Then you're able to access those members. So splasher, no, it's called the method is called splash. And then that method, that splash method, right? If we go to splasher, where's the splasher class? Color splasher. So there's color splasher. Remember it's a pure virtual function. So there's no implementation. So you see there's a pure virtual function, right? It expects you to pass a UJImage. So how are you going to pass the UJImage? It's simple. Remember this keyword, it refers to this current instance, which means we'll be able to refer to all of our instances of UJImage. Basically, any variable of type UJImage can be referred to by the this keyword. So I'm going to say this, but then if I just pass this, right, this is a problem. This just passes the address. This function, if you check this function, it expects you to pass a UJImage. After you've passed the UJImage, then it's going to get the address of that image. So it wants you to pass the physical object. So I need to go back here and dereference to point to that specific address to get that UJImage. And then that's it. We've delegated. So this is now delegation. We delegated our task of splashing the UJImage to the actual splasher, which does the splashing. And then we've done that. And then what's missing? Let me check my UJImage class. Is there anything missing? No, we're done with UJImage. Yeah, there's literally nothing missing now. We're done with UJImage. Now we can go to our inheritance or child classes and in our base classes, whatever. Now we can deal with the inheritance part. So let's go back here. So this is my color splasher, right? I think we did do a lot of things in the color splasher. Yeah, you see. Yeah, and then I choose one. Let me start with one. Let's start with noisy splasher. Okay, so now I'm actually left with the implementation. Then I'm almost done. Then we do file handling. So what I'm going to do is I'm going to start implementing the splash methods. So I'm going to go back to my PDF. Then I'm going to look at how it splashes, right? So a color splasher, blah, blah, has those things. And then it takes in an extra position. We did cover all this, right? So now I need the actual implementation of the splash method. And remember, we need to also add these files. I don't know whether I did add them. Let me just, okay, I can't view it here. Let me go to documents and then code blocks projects. And then there is, did I add those files? The txt, okay, yeah, there's the cities large file. Yeah, it is there. Okay, I did do that in the previous video. Okay, so let's see, how do you splash? Let's do splashing. Yeah, that's not, okay, where is it? Where's the talk about the noisy? Oh, so I'm gonna start with the noisy splash, right? So, let me see. Okay, so let's see. So circles of the same color can be splashed onto the image either using a noisy or solid approach. So there's basically a different approach of splashing the colors, right? Or splashing onto the image. Both approaches make use of two radii. Remember, radii is just plural for just a different way of saying radiuses. You can't really say radiuses. You just say radii or radii. Now it goes back to maths. If you're doing maths 1B, you should know what red-eye means when you're doing your discs and washers and all those things and volume and all those things, that topic. So the noisy approach looks through the image, right? So we need to go through the image, one thing at a time. So it loops through the image. So we need to loop through the image. So let's loop through the image. So this will be, I need to give that parameter a name now, obj image, since I want to make use of that, its value. So for unsigned short r is equals to 0, r is less than obj image, that image that I'm supposed to splash, dot get rows, and then r plus plus. And then for unsigned short c is equals to 0, c is less than obj image dot get calls, right, for getting the columns, and then c plus plus, and then there we go. Remember, we have our accessors. They are there. That's why they told you to create to design the class using the principles of good design known to you. So that means you need to use like create accessors and mutators and your parameterized constructor, parameterized construct, all those things, destructor, all of them. We did follow instructions and we created all of them. So then it does draw consisting of two radiuses for those. A pixel that falls within the smaller of the two radius must be drawn. So that means you need to check in what range does that pixel fall in, right? So let's say if the pixel falls within the smaller of the two radii. So in order to see whether it falls within the smaller of the two, you need to be able to find the minimum and the maximum between the two. So since I do not have time, right? Remember, this is an exam. This will be a semester test too. You won't have time. I'm going to use the functions mean and max to get those maximum values. So I need to actually get the minimum and maximum between, let me see. So I need to find which radius is bigger than the other, right? Oh, okay. Yeah, I don't have to worry. Okay, yeah, I remember. Okay. Remember, we called it smaller and larger. You don't actually have to worry about which one is smaller, which one is larger. Yeah. We actually do save and store which one is smaller, which one is larger. So it's protected. So I need to go to my base class to see what I've called. It's underscore smaller radius and underscore smaller larger radius. So how do we check if it's within that range? It's simple. You just say if, you just do an if statement, if my current pixel, right? I don't know whether they said the current, they said if a pixel that falls within the smaller of the two radiuses must be drawn with the 100% probability, right? So let me think. It must be drawn within 100% probability. Mm, how would you draw the pixel? That's the thing. They don't tell you what exact values to put into the pixel. So let me look at the other one. For each generated location, a solid circle must be drawn onto the image. Mhm. Only one of the two radii must be used to draw the circle. The radius used. Oh, okay. So we use the radius within the smaller of the two radii must be drawn. Oh yeah. So we are drawing a pixel, right? We're drawing a pixel based on what is based on we're drawing a circle based on whether the pixel falls within the range of the radius. So with that being said, then and this applies in both classes, right? You see, you must draw a circle. So we're drawing a circle in both. So that means I need to create a protected function, right? So noisy, color splash, because it's going to be used in both classes. But then I do not want to make I don't necessarily want to make the method public. It's not meant for the public, it's meant for me. So I'll put it under protected and say, so it needs to this, we need to have, I don't know whether we need to have two functions or not. Let me see. Yeah, I think we might need to have two functions. So I'm going to create the first function called, so what are we doing? We are checking if we need to draw a circle. In order to draw a circle, we need to find the distance. So distance formula, right? And then I need to find the distance of my pixel. So let me think. I need to take in a row and a column, right? I think so, if I'm not mistaken. Well, I need to take in X, Y, and X2, right? Yeah. So I need to take in unsigned short, okay, and then unsigned short. Then it just calculates the distance. And then the other one is supposed to draw a circle, right? So we call a function that draws a circle. So let me see. It draws a circle onto the image at that specific pixel. Yeah, at that specific pixel. Okay, I don't think I need, it's up to you, whatever method. If you don't want to create the method, it's up to you. You can just start coding there. That's fine. So what I want to do is I want to check, um, yeah, I want to use the distance formula, right? To check between the distance between the distance between my center and the rows and columns, if I'm not mistaken. Yeah. Let me see. Solid splasher, color splasher dot h. So this will take in an x and y, and then I'm gonna find a distance. Let me see. Should I actually implement the method here or put it inside the classes? Okay, so it actually needs 4 parameters. So I need to take in an x, y1, right, and then y1, and then x2, and then y2. So this is actually going to be a very long function when you declare it. So it's going to be like this, right? So it takes in an x1, y1, x2, y2. So yeah, because I'm gonna use this function often, so I'm gonna leave it like this, and then I'm gonna implement it inside color splasher. So that's why I'm putting it in the base class, because I'm gonna use it in both classes, both child classes or derived classes. So this will be x1, then this will be y1, and then this will be x2, and then this will be y2, right? But then remember, I need to use the math library, right? So I need to use the CMath. I need to include the CMath header file because I'm doing mathematical calculations here. So hash include CMath. And then I'm going to go back to my color splashes implementation file. And then I need to return the distance, right? What's the distance formula? It's the square root of x1 minus x2 divided by 2. No, it's the square root, not divided by 2. I'm mixing them up. It's, yeah, and the maths is not an easy thing. So the formula is x1 minus x2 all squared, right? Squared, so to the power of 2, plus y1 minus y2 to the power of 2, or all squared, and then this result should be put into a square root. You should find the square root of answer. So I'll say this, imagine this is answer, and then you find the square root of answer. So inside C++, there's a square root function. It's named sqrt. So I'm going to say return. It's in standard namespace, so I'm going to tell it it's in a standard namespace. There's all the mathematical functions. Hyperbolic, cos, hyperbolic, whatever those, and then cosine. So I want the sqrt, the square root function. So sqrt, square root function. And then this square root function, right, it takes in a double, right, to a value, and then it finds its square root. So I want to get the square root, but then remember this, you can use the power function, right? To the power of 2. There's a function in C++ called power or power, right? So it's power, and then you take in the base, and then you pass in the exponent. There's that function in C++. So what's the base? It's x1 minus x2 plus power again, and then xy1 minus y2. So that's what I'm going to use. So it's in the standard namespace pow function, and then plus in the standard namespace pow function again, or power function, and then it's the base is x1 minus x2, comma, to the exponent, which is 2, so squared. And then this will be y1 minus y2, comma, 2, or squared. And then this is now the function in full. This is now the distance formula. And then yeah, and then that's pretty much all you need. So I'm gonna go to noisy splasher, and then I'm gonna find in order to draw a circle, let me see. Yeah, in order to draw a circle, let me see. Because I'm thinking of whether or not I should create a separate draw circle method. That's really what I'm thinking here. Yeah, I think I should. And then since it's going to draw in both classes, but then the problem is if I create that draw method, right, that means it also needs to take in a UJ reference. Not really, okay, not really a UJ reference. Nope. Okay, yeah, it's going to need to take in a UJ reference, yeah. So let me not do that. That's gonna complicate things. So let me just draw within each child class. So let me see how many minutes it is so far. Okay, I don't want to make my videos too long, so we'll see. Maybe if I can do both of this, let me try to finish everything. If I see that I don't finish everything, that's also fine. I can move on to the next thing. So I draw my, before I draw my method, before I draw anything, right? I need to, let me see. I need to find the center of my circle, right? Yeah, I need to find the center of my circle. Which is simple because to find the center of your circle is just rows divided by 2 and columns divided by 2. So I'm going to say, and I want it in integer format, so unsigned short, I'm going to call it, let me see, x center, right? Which is the x value of my circle center, right? Is basically going to be UJImage dot get rows divided by 2. And then my y center is going to be dot get calls divided by 2, right? So since now I have the x center and the y center, now I can compare starting from my distance from my center to the current pixel and check if that distance it's less than or equals to the radius. So if it's within that radius, then I can draw a pixel so that it draws that radius, right? So I'm going to say if distance formula, right? or distance function. So what is my x1? X1 is like this, the first, and remember x in terms of pixels, right? Or code, x is typically the row, y is typically the column. That's the typical way. So x1 will be r, any row. I can choose x center or r. So I'm going to choose r as my x1. And then my y1, remember the way I've structured the function. It takes in x1, y1, x2, y2. So what is y1 is c. And then I need to go to x2, which is x center. And then what is y2, which is that y center. And then that distance that I found, if it happens to be less than or equals to the smaller radius, but let me see. Let me see, where is it? If it happens to be within the smaller of the two radii, it must be drawn with 100% probability. So if it happens to be less than or equals to the smaller radius, so underscore smaller radius, then I need to draw it with a 100% probability. So how would you draw a pixel with 100% probability? It's simple. The way you would go about drawing it, right, is that you'd say you generate a random value, a random number between 0 and 100, because there can be a 0% chance of it occurring, but there's also a 100% chance of it occurring. And then you check the range of that number. If that number is within, or you can do this, right? They said it is a 100% chance of occurring, right? Or you can just generate any random integer. If that random integer lies within the range of 0 to 100, that means it's within that 100% probability, then we can display it. So in order for us to do that, we need seed time, right? We need to make use of the rand function to randomly generate a value. So I'm gonna go to my color splash, which is my base class, go to the top, and then okay, where was I? Okay, yeah, I wanted to clear that, and then so I need to include seed time. So LMNOPQRST. Okay, I'm just checking. It's just something that I was thinking in terms of how you should include the header files. You include them alphabetically in alphabetical order. That's what I was thinking about. So I need to go to noise displeasure. And then here they say you should draw it to the 100% probability. How do I do that? So remember this first part, I check if the distance is within the smaller radius range. That's what I'm doing. And then I will have an else if to check if it is within the distance of the larger range. And they said if it happens to be true that it's within the smaller circle's range or smaller radius, you draw it with a 100% probability. What does that mean? It means that I generate a random value and it can be any number. But if that number happens to lie within 0 and 100, that means now there's a chance of it being drawn, then it gets drawn. So I'm going to generate a number. So I'm going to say, and remember they said it's within the probability of 100%. So I'm going to say unsigned short, and then let me see. So I'll create it outside, right? The variable. So unsigned short. Remember, I don't have to set it. Let me think about it. Let me see. Let me look at the pixel because I'm trying to understand how I'm going to use this. No, I need to UJcolor.age. Yeah, remember we also have the probability of that pixel being drawn. So since I have that probability right there, I could set it. I don't see the need, to be honest. I don't know how you're gonna use that. I don't see it. But you could remember they said it has a 100% chance of being drawn. Then what I can, okay, that's not necessary. Let me just leave that. Let me totally entirely leave it. I wanted to set the probability to 100. I could do that later. I'll do that later. Or I could just leave it. Let me just leave it. I'll just hard code it. So draw it with 100% probability. So I don't want to keep redeclaring that variable within. So I'm gonna say random. It represents the random value, right? So I'm just gonna initialize it to 0. And then here I'm going to say that random value. You can call it random or rand value or random value, whatever you want to call it. So let me actually write it in full. So if I just say random, it's like, what do you mean by random? So let me just say random value is equals to what? So I go to standard namespace and then I call the rand function, right? Which returns a random value, right? So since it's a random value, you see, you'll understand why I'm doing it this way. It's a random value, so I shouldn't apply the modulus to give it a range, whatever. There's no specific range. You should just generate any random value. But then if that random value happens to be within 0 to 100, or it happens to be less than or equals to 100, then I know that that pixel should be drawn. So after generating that random value, and then I'm going to check if the random integer is check the random integer is within 100% probability. Basically, you're just basically going to check if random value is a number between 0 and 100. That's pretty much it. That's what they mean there. But then you need to generate any random integer. So it can be any integer right there. Okay, I don't know. Let me see. Let me check something. I think the rand function returns a long. Since I'm not, since I'm not, remember, I need to be very, very careful here. Since I am not restricting or specifying what specific range the integer should be in, it can be in any range. So that means I think it's going to use the long data type. So rand function in C++. Um, yeah. Is it okay? Yeah. So you can go to c++.com to get documentation on every function or everything on C++. So you see, it starts with 0 between that. Yeah, you see. So I need to find out exactly what type does this rand function return. Um, okay, yeah. So it returns an integer, right? It returns an integer. So this function returns an integer. Since it returns an integer, that means its range is going to be within the range of an integer. So I'm going to say int here. I need to be very careful because remember, I'm generating any random integer. The maximum of an int is 2 billion. So I'm generating any random value between negative 2 billion and 2 billion. So that's very big. So I need to put in the right appropriate data type. Then now I check if random value is less than or equals to 100. Mean that it's within the 100% probability, right? Simple. It's pretty much that. Then once I know, I can draw the pixel. So I don't know what color to set it. Let me see what color did they use here. What shade of blue is this? Um, let me see. Okay, let me go here. Let me check this file. I don't know what they saved in this file. They saved the Don't show again. So they save, okay, this is the probability. So yeah, there's no color here. What is color blue? Oh, it's just a maximum intensity for blue, right? Yeah. Yeah, it's maximum. I mean, the maximum is blue. The other color components are zero, and then blue is its maximum. So I'm gonna make the pixel blue. So how do I do that? You say underscore pixels at a specific row and column. And then remember to set mount. Remember, this is a record structure. It's type UJ color. So there's multiple values. So I'm gonna use the list initializer. So what's the value? It's going to be 0 for red, 0 for green, and for blue is 255 maximum. And then you could also set the pixel, the probability value to 100. You could do that. Yeah, I could do that. Let me see. Let's look at the probability thing. Let me see. I don't think it was necessary though, but it kind of seems like it. A single pixel for a color image is defined as follows. Probability, blah, blah, blah. Yeah, they all have a single probability. I don't think it was based on the problem statement. Now, when I look at it, I don't think it was necessary to put probability within the record structure. I don't think it was necessary. You're only supposed to put UJ color. So that's why I'm confusing that part. So that you're not supposed to put in that probability there. Just leave it out. So yeah, because I don't see where it's being used here. Yeah. Okay, they said when the image is created, every pixel color component should be set to 254, right? And the probability of being visible must be computed randomly using the current time as the seed value. Oh, we're not done here. I didn't see this part. So when the image is created, that means within the constructor, we needed to set the probability random. So it's fine. It is for every single pixel. Yeah. Yeah, it is for every single pixel. But then they said randomly using the current time as the seed value. Okay, this that means it's going to be random, the probability. So we just need to use the rand function. So there's quite a lot of things I need to change. So I need to come here and change this to an int because I'm using the rand function. Remember, the rand function can store, it returns an integer. That's why I'm changing that to an int. And then I'm gonna go to noise splash. No, not noise splash. Where am I supposed to go again? UJImage. UJImage was CPP, but then I need to start with the UJImage.header file. And then I need to include the ctime library. Ctime. And then if you go to, okay, that's fine. Ctime, yeah. And then I'm gonna go to UJImage with CPP. UJImage is the implementation file. Then I go under constructor. And then under constructor, we need to set the probability. Like I said, we were not setting the probability here. So we need to set the probability. So I guess this pixel that we're taking from the user will just be a normal pixel. So I need to set the probability. So, and they said for each pixel, let me check every pixel's color and the probability of being visible must be computed randomly using the current, yeah. So I must compute it randomly. Let me see. Yeah, I must compute random. The probability should be random. Yeah. Oh, so I was actually supposed to set the probability here and then use it at other side. Now I'm starting to see the flow. So underscore pixels, the specific row and column dot probability should be set to the rand function, right? I think it's in a standard namespace if I'm not mistaken. So standard namespace, and then that's going to return a random function. And they said you need to seed using the current time. So I'm gonna come here and seed, but then inside main, I think it was seeded. Yeah, there it is. They did seed the random number generate. So I don't have to worry about seeding. So yeah, we need to set the probability randomly every time. So that means we have the probability set now. I do not have to generate it again that side. I just do an if statement. So I do not have to do this now. Remember, it generated that side. So now all I have to do is actually get the pixel. So I'm gonna say obj image dot get color, right? Dot get color for that specific row and column. Then dot probability, and then check if that probability that we've set, if it's less than or equals to 100, then change the pixel to blue. That means draw the pixel. Yeah, it's a subtle change, but I didn't see that part. That totally ignored this part, which is bad because you need to read everything. So we don't compute the pixels that side. The random generation, we don't calculate the probability inside the splasher. We calculate it inside UJImage. Because when they told you when the image is created, that's when the UJImage constructor is called, right? And then two for loops, and then a pixel that falls within the larger range of the two. Oh no, I'm wrong. They said with 100% probability if it's a smaller circle. Right, so if it's a smaller circle, oh yeah, I see now. Remember, probability is going to be on the right-hand side of the less than or equals to. So this is wrong. So let me do this. Let me put back that one. There we go. So I would check the random value and then check if the random value is less than or equals to 100. That's what I'm using. That is my probability. Else, right? Else if the distance is less than or equals to the distance of the bigger circle, so larger, that means it's the same radius as the largest circle. If it is the same distance as the largest circle, yeah, it's the same distance as the largest circle, then I'm still going to generate a random value, but then the probability changes. So it's the exact same thing as this, right? But then the only difference is that they said it's not within 100% probability. It's between the probability that was assigned, you see, using the probability assigned to it when it was created. So that's when I need to call that probability now. So obj image specific row and column dot probability. So I get that probability. No, what am I doing? Dot get color, right? And that specific row and column dot probability. So I check that random value. If it's within the probability that was set when the image was created, then set it to this pixel. I hope it makes sense. So yeah, I think this should suffice. This is fine. Yeah, then oh, they said set the pixel. What am I doing? Yeah, you see now. Remember this underscore pixels array is not available here. I need to use my object. So dot set color or set pixel, whatever you want to call it. I've called it set color. So that's where the specific row and column set it to that pixel, this pixel over here. So set it to that pixel. And then I copy and paste the same thing. Because we need to do that through accessors and mutators. Because we didn't override or overload the indexing operators in this one. There were none. So we can't use that. So we have to use mutators and accessors. So the solid approach randomly generates several locations, row or column coordinates from the image and only draws solid circles around them as follows. So let me look at the video. Yeah, let me pause it here. We'll continue from solid approach. Then we'll do file handling. And then we might end it there. Then another video will do the bonus. So that's it. Thanks for watching. See you in the next video.